Okay, guys, we're going to do now a couple of quick videos about the multiple representations practice that we did in class. So first I'm just going to work on number one here. That's the left-hand column. Now on this one, notice it gives us an x versus t graph. So they give us this graph here. And what I have to do is I have to convert that graph into a v versus t graph, and then a written description and a motion diagram. So let's see if we can do that. So let's get started. Um, First by creating the V versus T graph. Now, I told you guys in class to just go ahead and label this thing, so I'm just going to do it. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, and we'll do that here. We'll go 1, let's go closer. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, good. All right, now I've got it labeled. Now, in order to be able to put a velocity down here in my velocity versus time graph, I have to figure out what velocity is first. And on this specific graph, there's going to be two different velocities. So specifically, there's a velocity for this section, and then there's a different velocity for this section. So we need to figure both of those out. Let's start on this lower section. And I'm just going to notice that I've got a point here and a point here. Now there's a couple ways to think about it. We can think about it as rise over run. We can think about it as xf minus xi and over tf minus ti. I'm just going to look at rise over run. So I know that I've got my rise and run there. Now if I look and I see I've got 1, 2, 3, 4 is my rise, and then 1, 2, 3, 4 is my run. Okay, so that means that rise over run is going to be 4 divided by 4, which gives me 1 meter per second as my velocity. Okay, next let's deal with this upper half. So I've got a point here and a point here. Now a really common mistake that we saw today was for people to try and do 8 divided by 6. And that's not what we want to do. We want to do rise over run. So again, we have to count 1, 2, 3, 4. Now just counting works because my scale is really easy here. Then I've got 1, 2, so we'll count that there. Now rise is 4, so that goes on top. Run is 2, so that goes on bottom. So 4 over 2 is 2 meters per second. Okay, so I've got both my velocities. Let's go down and let's see if we can't translate that into a velocity versus time graph. Now remember my big hint. Anytime I've got x versus t up on top, v versus t down below, go ahead and make your time scales exactly the same. So we go ahead and make it 1, 2, 3, 4, 5, 6, 7, 8, 9. Now I'm also going to have to go velocity scale, and I look at my velocity and I see all I really need to include are 1 and 2. So I'm just going to count my ones because that'll include everything and it won't go too terribly high. If some of you guys counted by like 1 every 2 lines or something like that, that'd be fine as well. Okay. So I know that between 0 and 4, so in this section of my graph, I've got one velocity. And that velocity is 1 meter per second. So I'm going to go ahead and from 0 to 4, down here, I'm going to draw in a velocity at 1 meter per second, okay? Got to make sure you notice that that's at 1 meter per second. So that's the reason that's there. Okay. Now if I go back up, I see that my upper part here, that's from 4 to 6 seconds, and it's 2 meters per second now. So I go down here, and now I'm going to go up a step because it's a little bit faster, and notice again that that's 2 meters per second. So that's the reason that's there. Now I'm just going to put, just to show that this is the same object moving, I'm going to put a little dotted line there. Okay, and that's it. That's all I need for my velocity versus time graph. I can show that I've got constant velocity from 0 to 4 seconds of 1 meter per second, and then more constant velocity of 2 meters per second as time goes on. Okay, let's go ahead and do my written description. Now, written description. I just want to describe the motion of the object. So there's a couple things I want in there. I want direction, I want speed, and if it's changing speed, okay? So we're going to say something like, okay, object is moving. I'm going to go ahead and make that a little smaller, okay? Object is moving away from 0 at 1 meter per second. Then it speeds up to 2 meters per second at 4 seconds. Okay, so object is moving from 0, away from 0 at 1 meters per second. Then it speeds up to 2 meters per second at 4 seconds. So if we look here, so it's moving away from 0 at 1 meter per second until it hits 4 seconds, and then it speeds up to 2 meters per second. Okay, good. Now I need a motion diagram. Okay, so I'm only going to, for my motion diagram, let's make that black. Okay, so my motion diagram, remember, every good motion diagram just starts with an axis. All right, so I've got my motion diagram, or my axis there. Now it starts at 0 and moves away, so I know it's going to move left to right. And it starts off going 1 meter a second, which is kind of slow. So we'll do that kind of thing. Now remember, I have to have arrows in between my dots. Now when it speeds up, my dots get farther apart, and my arrows get longer. So there's my motion diagram. So we see that in this section, it's slow because the dots are close together and the arrows are short. And in this section, it's fast, and that's what we see happen up here. We see it start off slow in this section, and we see it get faster here. Okay, there's number 1.